Hello, everyone. Welcome and thank you for joining us today. This webinar is a bit special as it is the last Grey Scott Thursday session before the start of the Grey Scott School. So first of all, we'd like to thank you all for your enthusiasm and support throughout this series, beginning in January. We're delighted to announce that we are approaching 800 registered participants for the Grey Scott School. So it's going to be a great edition and we can't wait to meet all of you very soon, whether you'll be joining us in Annecy or from one of our 17 satellite sites across Europe or online. So we sincerely hope that you'll enjoy this training. You will learn a lot, meet new people, and take away valuable skills that will benefit your projects and future work, hopefully. So before we begin, I would like to remind everyone one important thing. Please make sure that you join our Discord server. I put the invitation link in the chat. Discord will be our main communication platform during the school. So we strongly encourage everyone to connect. There you will find a program channel with a complete schedule for the 2 weeks. You will find another channel where you can contact us, the organizers, directly whenever you need assistance. You have another channel which is called Grey Scott School Live, where we will publish all the streaming links every day to access the lectures and the live sessions. And finally, there will be a channel called Question for Teachers, where you'll be able to ask all your questions during the school and you will receive answers from the instructors. So we will also continue enriching this channel and the server with useful information in the coming days, so please connect. It's the perfect time. One last thing about Discord, please don't hide behind the mysterious nicknames. When you join the server, make sure that you use the same first name and last name as in your Grey Scott School registration. This is very important for us. This helps us to identify you and follow the attendance, and so prepare your certificate of participation at the end of the school. So please take a minute to update your profile if needed. It's very important for us. Thank you for being part of this Grey Scott School community. See you very soon.
Could a simple chemical reaction teach you how to unlock peak performance on today's supercomputers? Welcome to the Grey Scott School 2026, a free, advanced summer school on high-performance computing. Designed for professionals from industry, public sector organizations, and academia. From June 22nd to July 3rd, 2026, join us in Annecy, France at LAPP, at one of our satellite sites across Europe, or online via live streaming. All courses are taught in English. You can pick the courses most relevant to you or dive into the full 2-week program. You'll learn the practical behavior of modern hardware and how to write performance-optimized portable code. Week 1 focuses on CPUs, Week 2 on GPUs, covering architecture, bottlenecks, parallelism, memory, and performance analysis. All learning is built around a single challenge, simulating the Grey Scott reaction. Simple to start, yet complex enough to stress compilers and expose performance limits. You'll explore modern tools, languages, and libraries such as C++ 17 and 20, CUDA, Fortran, Python, OpenMP, TBB, Kakos, PyTorch, and more. The school provides ready-to-use container environments for smooth hands-on sessions. Expert instructors from CNRS and CEA guide you with live Q&A and community support on Discord. Satellite sites let you learn together locally without traveling. Want to host one? It's easy with our turnkey setup, sharing the school with your colleagues and ecosystem. You'll leave not only with hands-on HPC skills, but also an official certificate of participation. And you know what? You can start early with 18 Grey Scott Thursdays webinars, weekly from January 29th to June 11th, introducing summer school concepts and new topics. Whether you're an industry professional, engineer, researcher, or student, if you have programming experience and want to push your skills further, this program is for you. Register now at cc-fr.eu and start learning today. Grey Scott School 2026, Europe's leading HPC summer school.
So here is the Grey Scott School server. You have this welcome channel, the program and registration channel, as I told you about, with the schedule for the 2 weeks. You have here the organizer contact channel, where you can already ask us anything you need. We answer you quite quickly, I hope. And here you will have the channel where we will put all the daily links to access the video and the live from the teachers. And here, the questions for the teachers. So if you have any questions from now on, you can use this one to contact me and Karim and Pierre. And if you have questions about the lectures and the courses, here for the questions for teachers. So if you have any other question how to use Discord, don't hesitate to contact me.
Okay, so now I will present to you how to use the images of the lectures. So if I'm starting from here, so I'm on the EuroCCFR webpage. I here in this Grey Scott School page, and then I jump here. So here you get all the explanation, all the webinars of the summer school. You already know, of course. Get that around the last 6 months. And so here we'll start with the container list timetable here. So you get basically all the containers information, practically all. I have to update a bit some of them, but you get Cocos here. You get the image that we will use here also today for the demonstration. And basically we have 3 types of images. So one light image, basically if you want to use a job scheduler for HT Condor, Slurm, stuff like this, you have light images, so only the very few dependency that we need for the lecture itself. Then we have the code server, the interactive code server images. So the idea is to integrate a code server inside the images, and you can start the image and jump with your favorite browser on the image, and you get everything set up for you. So of course, if you want to use another editor, maybe we can see that also a bit later. So to use Pixie, but it will be just after that. And we have also Jupyter Hub images, so for the Jupyter platform. And basically we do that with Kubernetes here. They're on Kubernetes, so this is the link for Must. I'm pretty sure you will have all the link, for example, for Maison de la Simulation or the satellite site with a learning platform like this. And let's start with it. In fact, so if I go here, of course, I need an account. So if you attend in the lab, you will get an account to connect to this. And here we have Grey Scott 2026, and here you can pick few lectures, not all yet, but they will come, of course. We are testing everything, and everything is exposed when it's working. So let's pick the performance with Stencil C++. Then I can start iPod. Okay, and here you see we have a README. We go in the example directory, so inside the home directory. So Jovian here, because the convention in Jupyter to have a Jovian user. So here you can jump directly into the lecture, so you can follow the lecture step by step. Of course, this is a really long lecture, in like 700 pages. Of course, we will not dive into the whole lecture during the school, but you will get extra material, of course, to get all the details that you need for specific implementation. But you will get few of them to I will try to give you a nice story for the lecture here. And then we have the example, and we get CMake. So CMake 4, I believe, normally. Yeah, 4.3. So a really recent CMake, really recent compiler also. So yeah, G++15 we get. So we will do some magics with that, of course. That's why we use Pixie here to get the very last compiler and everything nicely. So here the point is to do as usual. So make dir build. So I create a build directory. I go inside the build directory and then I call CMake. Of course, the point here is we get the information directly with Pixie. It's not a standard installation. It's an installation inside the home of the user, inside the Pixie, in fact, the .pixie inside the home of the user. And so CMake cannot pick all the compilers, of course, by default. So I'm in my build directory here, and I can do CMake Phoenix. So I can print you the alias to explain you what's going on. So here, CMake Phoenix, I will call CMake ... to get the parent directory, as usual. And I explain to CMake that, okay, my install prefix is will home Jovian Pixie env Grayscott, so GS, and my CMake module path is this one. Otherwise, of course, pick the wrong compiler, the wrong everything. So I don't want that, of course. And here, if I call CMake Phoenix, I will get my G++15, I will get all my dependency right, and everything is okay. If I do that, now I can compile. So here in the image you get CMake and you get Make and Ninja. So if you prefer to use Ninja, here I will do the presentation with Make, and maybe I can show you that, of course, I'm not in my laptop. So nproc 64, of course I don't have 64 cores on my laptop. And if I do make -j nproc, I can compile everything at once. So it should be fast. Okay, so here I compile everything inside build directory, and now I can do the same with a plot all command. So the idea is we will dive into a lot of performances, maybe not all, but you can get all the detail, of course, if you want to have a look. And here I have command to compile everything at once. Of course, it's not a good idea to perform performance test at once here, but just to show you what's come out of it. Of course, we'll do it one per one, gently during the lecture. Be sure that everything is clear. And of course, we will compile here in O0, O1, O2, O3 with vectorization without to see what to do, what not to do. And of course, O0 example is really slow. So we have to wait a bit. It should be quite okay now. Come on. Okay. And so here you have in the build directory, you get a performances directory. And in the performances directory, you get all the results I just compiled here. If I do that, I can have open in images preview. So it's a quite recent update from Code Server. And here you get all the images. I will not show you everything, not to spoil you too much. And here, if I click here, I can embed the images here. And if I get this one, I can have a big or whatever you want. So everything is under control, and here everything is working. The last point is how to stop the pod. So here I remove my tab. Of course, the pod is still running, so if you connect again, or maybe I can show you. If I connect again, I will get back my pod. No problem. And I get back my pod with my performances results. No problem. If you have a deconnection, don't worry, you will not lose everything. But of course, once the pod is stopped, nothing is kept. So you have to save all your work if you change some stuff before stopping the pod. And to stop the pod, what we do is to do that. So here I have my pod running, I click stop my server, I wait 2 seconds, and normally the pod should stop. Yeah, and here the pod is stopped. No problem. So that's for the first part, how to use a pod. Now we will do interactive part in code server on a laptop. So here you see I get a lot of lazy commands. So the idea is you get the URL here of the code server image itself. So you get the same, of course, for Cocos here. You will get the same for all the other, but they are working for the final touch of their images. And here you get the command to pull the image with Podman, to run the image with Podman, pull with Obtainer, run with Obtainer, pull with Docker, and run with Docker. Of course, for this here, since it's quite different install, it's much simpler to use Podman, but you can use Obtainer still, and with Docker you can also use, but you will get some problem because of course the rootless, it's broken once over 2 times, so it could be quite annoying. So if I want to pick one image here, so of course I can jump on the lecture here and get the lecture here, and you can follow the lecture here as well if you prefer to use another stuff to follow the lecture. Here I can pick here, I can paste here the full command to pull, so don't worry, you don't have to do the copy pasting. So of course I already have the images here, and then I can say okay, now I want to run my pod, so I do that, paste. Here you get podman run -it, so interactive, -rm, so I want to remove the container itself once it's done, otherwise it will stay, and of course you don't want it to stay. -net equal host, otherwise you will not be able to connect to your code server when it's running, and finally the URL of the image with the digest, so you be sure that I don't trick you and it's the right digest, there is no another lecture here. And once I start my podman here, so I have this address, I can jump on this address on my favorite browser, no problem. And here I was already connected, so I don't have to type the password again, but of course if you are not connected, you can have normally the password here, so it's generated on the fly, so you get this one, you copy paste it inside the login, you will have a little login here. So of course here you get the same information, you can jump on the lecture inside the readme, no problem. And here, so I'm on my laptop, so I don't want to break everything because there's the captation here, but here it's the same. So here, if I do nproc, I have only 24 cores, it's only on my laptop. I can do the same, so it's exactly the same environment, so I have to do the same trick with the CMake Phoenix as I showed before. And here I have to create a build directory. Of course, if you prefer to call CMake in another way, to call Ninja directly or make directly, you can do everything you want. Of course, everything is flexible, you can do what you want. And here I can do CMake Phoenix, and I can compile everything. And then I can compile J24, okay, and then I can do a plot all, for example, as before. Okay, and here, as before, of course, I have my build directory, inside I have a performances directory, and here I can pick all the image in preview. Of course, the performances are really bad because I run all the performances at the same time, which is not a good idea, of course. But just to show you that everything is compiling, everything is working, just that. And that's it for the test with Podman. So here, if I close tab, I can Control C here, and everything is stopped, and no problem. You can do exactly the same with Obtainer, but Obtainer will mount automatically your home, and you will have to put the password to log in your session from your home. And of course, I will not share you the password of my home, of course. So you will have the same behavior, but the password will be not inside the image itself, but it will be inside your home your real home. So you have to have a look to that. And that's it for the interactive part here. And we will jump to Pixie. And so to run Pixie, we have to go in the local Pixie on laptop. So here, basically to start a Pixie shell, you have to just call Pixie shell, and Pixie will figure out how to create the nice environment for the lecture itself and create a shell for you. Of course, Pixie environments are not really well separated from your system yet, because Pixie is still in alpha. So you can have several tricks to make sure that everything is working. We can say, okay, let's define CC, CXX, and CF variables. You can do that, of course, not in your bash RC, because of course it depends on which Pixie environment you want to use. So this could be quite annoying, but we can do the same also here with the function. So I use that, for example, here on my laptop, so you can copy, of course, if you want to have a look. And here I will tell CMake, okay, I'm in Pixie environment, so I want to get my Phoenix CMake config here with the parameter I showed you before, just for the right Pixie environment. And I define my CMake C compiler with the right path, and my CMake CXX compiler will be okay. So here, basically, if you get the example here from this lecture, of course, we'll work with all the lectures. You get the example, you enter the example, you win the example, Pixie shell, and then you create your build directory. You can call CMake Pixie, and you can start to compile everything and to run all the plot as before, no problem. If you prefer, of course, to use a CMake with another command because you prefer to use the -j with Ninja, whatever, you can, of course, change it, no problem. And if I do that, so here I'm in the example of the lecture here, and I can create the build directory. I can go in the build directory. I can do a Pixie shell inside the directory, so it works like Git, for example. So if you are on a subdirectory and somewhere in the parents you have a Pixie toml, and Pixie will get this one and start the shell for you here, and do that. So of course, if you have nothing ready yet, Pixie will download everything for you to have the environment working, and then I can do CMake Pixie, and I can start. And here you can see, of course, the paths are really long, of course, because I get my GCC here, my G++ here, my HDFI with really long path here. So it's a bit long, of course, a bit more verbosy than before. The same for the dependency here. And here I can compile. Okay. And then I can plot everything as before, of course. Okay. So I get everything compiled, all the tests as before, and then I can jump here in my example. I get my build directory, I get my performances, and here I have all the performances as before, no problem, everything is good. This is working well. So I Control D to go out of my sub terminal here with Pixie. And if you prefer, you can also say Pixie run test. So there is a test task inside the Pixie. You can also change the toml if you prefer to have extra tasks. And then I can compile. So here I compile with Ninja. I run all my tests. Okay, and that's it. So you can also do that. So Pixie run test. Here there is a task. If you want to jump into the lecture with another browser, with another editor, you can do Pixie run, for example, Z, and you will start Z inside the environment, for example. Yeah, for the GPU, so I didn't updated the documentation yet. It's my fault, but of course you can use the containers of GPU, the containers designed to do some GPU. Of course, if you use the CPU container and you use the GPU, nothing will happen because we don't have the dependencies. But we have dedicated container for the GPU, so container with the HPC SDK, for example, or I'm working on a container with a lighter container with Pixie to get only the compiler I want, because 9 GB of HPC SDK is a bit too much. But for now, it's Pixie is not really cooperative. We can mix Pixie with HPC SDK bare metal installation, but we cannot mix Pixie with NVC++ install inside Pixie via CondaForge. So that's a mystery for me right now, but we try to figure out that for the school to be sure that you don't have to install the HPC SDK in bare metal. Otherwise, we will get images which are a bit big, and we did that last year, but still have hope to optimize that a bit for the school.
Thank
If
you.
you get here and you jump on the local container on laptop, you get a demonstration video. It's a bit long, but I mean, you get all the information here. So you have all the relevant information to pull the images, to start the images classically with the CPU, and at the end, we have all the important information to start on a GPU. So with the -NV for Aptainer and the GPU all device dev DRI for Podman and for Docker. So you make sure that you don't forget them if you want to use them. So of course I will do the same with the lazy copy paste stuff, but I didn't have time to update the documentation yet. But of course it will come at some point, so it will be ready for the lecture. And the point also, the trick for Aptainer is in Aptainer all the images are read-only. And once you want to follow a lecture, it's quite annoying to be obliged to change a directory and to mount a source directory to be able to edit it on the fly. So I use just the variable tmpfs to tell Aptainer, okay, I will not edit much, but it allows you to edit the images up to 50 megabytes, something like that. So it's largely enough if you want to change some sources, some commands to play with the block sizes, the image sizes of this. So it's okay for this purpose, but we still need a build directory to build a big part of the lecture, of course. Otherwise, Aptainer will complain, and normally should be okay for this question. Question from Vinak. Yeah, you can find the. I just show here. So here you get all the things to do if you want to follow the lecture with a laptop, with a remote server. So because of course you can jump to a server, dedicated server, and then you start the lecture from here because you have much memory or you, for whatever reason. So don't forget to forward the port here with the SSH command. Will be better if you can do that. And you have the job submission here. So mainly with Aptainer, I believe, normally. So in Mus we use htcondor, but you can use also Slum. So here I have a little archive with the job submission for htcondor. So here you get the configuration of htcondor to run properly on Must. And get the job to run also on Must, and I get the script inside the container to call cmake to compile to do some stuff if you want to do it automatically, of course. And here I have the Maisonette documentation from Arno. So if you want to use Slurm, you have all the documentation here also to use Slurm. That's basically quite the same idea, but you don't have to create a configuration file in Slurm. So normally it should be straightforward to do that. And the same for Kubernetes. So it's for Must, but it's quite the same idea, of course, for all the learning platform of Maison de la Simulation, for example, or the other, if you have other. So it's not a problem for this one. And normally you get all the command here also to pick your favorite container manager, and then you can also copy just URL if you prefer. For example, if you have a learning platform, if you want to pick this URL to update your learning platform, you just pick the URL and it's okay. It will come for all the others, but of course it's not, everything is not quite up to date yet, but it will be. That's my fault. I didn't have time to do it, but it will come. And normally should be okay. A question from Luc. Is that why Obtainer not being modifiable? I see binding option for Obtainer, but not for Docker. Yeah. Inside Docker or inside Podman, you can modify everything you want. Inside Obtainer, you can't. Everything is read-only. But you can use TMP, writable TMP if it's just to have a bit of margin, but not too much. Several tens of megabytes, not much. But yeah. So if you want to have flexibility, but you still want a container, I recommend Podman for this year, especially if you have a laptop. If you prefer the interactive, the bare metal way, use Pixie. Otherwise, you will struggle with all the installation, installing G++ 15, stuff like this. I did not mention, but we use CMake 4 also, 4.3, I believe, if I remember well. So everything is upgraded. So better to use Pixie, otherwise you will have a problem and you will say, okay, I don't have the right compiler, I cannot compile the C++ 23 stuff. That's why we use Pixie also this year for the school. So you can do bare metal installation without struggling with the installation itself. So it's quite better. A question from Lucas regarding the access to the course material. Unfortunately, I can't install any of the provided container. My laptop, my work is blocking them. My work is blocking them. Thus, all the course will be available using Must Code Jupyter Hub. Practically all, not for the GPU because we don't have GPU yet in the learning platform in Must. So that's the only limitation we have on Must. But depending what we can do, of course, you can jump on a GPU with HTTP. That's totally possible. So we have to figure out if they allow us. But if you are not too much, in this case, it will be possible. Question from Joshua will be the same for the online participant. You have access to all the containers, so I recommend for the online participation, maybe if you have Podman or Pixie, you can pick one. Would be quite nice. Pixie tries to be a bit smart, so if you have one Pixie environment for all the lecture, Pixie will try to make sure that you don't have duplication of your dependency. But if you have several containers, you will have the duplication. So maybe if you don't have too much memory on your laptop, that's my case also. So maybe Pixie is better for you if you have a laptop. If you have the space and you don't want to be bothered with installation, you can use the Podman, no problem. Okay, so Joshua is happy. And also, yeah, new stuff compared to last year. All the containers, not all yet, but at the end, they will be all compatible. All the containers will be multi-architecture and multi-platform. So you pick the container, whatever, if you are on ARM or on x86 or MD64, the container will take the proper part and you will be able to run. You don't have to figure out as last year, okay, I'm on ARM, so I have to use a completely different part of the URL. So it will be much simpler for you. So it's much more complex for us. That's why it takes time because, of course, having something compatible with everyone is horrible. But it's better to follow. So we do that for this one. So that's why also we have way less container than last year because, of course, we managed to have one container running for two architectures. So simpler for everyone. And of course, if you are in a satellite site or if you attend the school in Nancy, you can do everything. Last year, some attendees did the full experience. So running the test on their laptop, running the test on Jupyter Hub, and running the test on the Must with HT Condor. So for the other satellite site, of course, it's possible. You can choose to follow everything and compare your laptop performances with the job performances, with the interactive learning platform performances. You can, no problem. And you will see, of course, if you are a lot on the same learning platform, that you will have some bias in the performance result. That's normal, but that's also a part of the formation. You need to spot the moment that you are tricked by the system because you are not alone and you have a bias in your result. So that's another thing that you can do with the school. And maybe for the building of all the images, since they start all from the same layer, normally if you figure out how to run one of the lectures, normally you are okay for the other. Of course, it's better if you have time to test, but they start with the same layer each time. So to do typically the stuff to start code server properly, to connect to Jupyter Hub properly, stuff like this. Or maybe if there is some people from Computing Center joining us also today with Jupyter Hub images right now. We had several functionalities, so I did that with my colleague in Must. So now, if you need that, it will not be the case for Must. We don't need that for Must, but if you need that, it's possible to mount another volume, an extra volume, inside the container we are running on the learning platform with the installation we have this year. It was not possible last year. We upgrade everything, so Jupyter is upgraded, everything is upgraded, and of course everything was broken because that's life. So now we have extra functionalities. So if you want to pick the first layer to make your own lectures, it's okay. Of course, it's okay. It's the purpose of the school. So. Or maybe I can finish with a good point for at least the participant in ANSI. So we figure out to command all the meal for lunch. So the lunch is free if you attend the school in ANSI. Of course, at night for the dinner, you can go everywhere you want because, of course, it's ANSI, it's summer, so it's better if you can visit a bit. Okay, thank you, Vincent.
Isabelle has a last question for you, Pierre.
Okay. I am able to, if I am able to connect interactively to server, I may use the image local container. This one, you mean? Okay. Yes. Yeah, this one. It's another code server with Microbamba because it was not possible to use Pixie yet, but now it's possible. So yeah, if you manage to use this one, of course, everything changed a bit because now it's Pixie. So as I say, you have some trick to do to make sure that CMake will be cooperative and works well with the installation. But that's the only stuff. Otherwise, everything is the same. So the commands are the same. Just inside, you have to change a bit. But
okay, do you have other questions for Pierre? Don't hesitate to put on the chat. I'll have an eye on it.
Okay, and Joseph is happy too. Not sure we missed some question. Okay, Bandara is happy. And of course, yeah, while I will finish to upgrade everything, we'll be able to have all this lazy stuff available for all the images, of course. So you don't have to be bothered with remembering the right command to start the right container, because of course that's not the purpose of the school. Everything should be simpler than last year, at least. So, okay, thank you, Isabelle. Thank you, Valentin. Okay, if everyone is happy, normally that's the time to stop. Except if you have something to add, Marie. But yeah, thank you, Vincent.
Okay, just for you to know that on our Discord, you should be all connected to now. There is a new channel called Setup Support. If you have other questions to prepare before the school, you can now ask them on this channel, and we'll have a look at it and answer you, of course.
Okay, thank you, Ismail. Thank you, Chris. Thank you. Thank you all. Okay, we have a lot of thanks in the chat. That's definitely the time to stop.
And the courses, yes, Bokar, I think you were not here at the beginning. You have to connect to the Discord, and on the Discord, you will have the access to the videos and live from the teachers. So all the courses will be available here, and you will have another channel for all the questions you may want to ask for the teachers. So everyone should be on Discord, and we'll meet you there on Monday 22nd, so in 11 days from now.
And of course, if you have specific question to specific lecture, you have a dedicated channel for this lecture.
Well, thank you, everyone. I think we can wrap it up, Pierre.
Yeah. Thank you, Mohamed. Thank you, Mohamed. Thank you, Johan. Thank you, Bokar. Thank you, Isabelle. Everyone is happy, Fabien. Thank you, Fabien. Okay, that's
If
definitely.
everyone's happy, we're happy.
Or maybe for the last one, maybe you can close the session because I did all the others. Or you
Oh,
prefer?
thank you.
Huh? Yeah. You did the opening, I do the closing every time, but maybe you can do the opposite.
For the last one, thank you,
Okay,
Pierre.
thank you, Amadou. Thank you, Leonardo. Thank you all. Thank you, Yassine.
Yeah, I will add again the Discord
Thank you,
link
Jack.
for Bokar. Oh, thank you, Jack. Okay, thank you, everyone. We were very happy to have you all with us today, and for all those who were with us during all those Grace Cut Thursdays webinars. So all the replays are available on the YouTube channel. And now it's time to prepare for the school itself. We're very, very happy to meet you all in less than 2 weeks now. So let's meet there. Please connect to Discord and ask everything you need. We're here to help, and we are dedicated to Grey Scout School until the end of the school. So don't hesitate. We'll be very happy to help. We just want you to enjoy the school as much as possible. And thank you very much, Pierre, for this school and for letting us work with you and organizing all this. It's a great adventure with you. So
thank you for supporting us also.
That's great. Thank you. Bye. See you soon.
Thank you. Bye. So hi again. Hope the sound is better now.
The sound is much better.
Okay, so that's why one my question: is it a good idea to do some performance computing live demonstration while you are streaming? So it's definitely not a good idea. Okay.
At least through WebEx. We won't have that same problem during the school. Don't worry.
Yeah, but at last we make the science progress today. So now we are sure it's not a good idea to perform high performance computing test on your laptop while you are using WebEx. Okay.
Exactly.